Hello everyone, today I would like to show you how to find inverse of matrix and the easiest matrix is 2 by 2 matrix, and to find its inverse is very easiest. Let me to give an example and to show you how to find its inverse. For example, matrix A, B, C, D, and for finding its inverse, first of all we have to find its determinant, and determinant formula is multiplication A multiply D minus C and B. Yeah, and after its inverse is equal to 1 over determinant A multiply we change its place D A, and we change its sign minus B and minus C. Let me give an example. For example, matrix A is equal to 1, 2, 3, 4, and to illustrate this point we have to find its determinant. As I said before, determinant A is equal to AD minus CB. 4 minus 6, it's equal to minus 2. The determinant is minus 2, and A inverse of A is 1 over minus 2 for 1 we change its place minus 2 minus 3. If we calculate we can find its inverse. Let me find 3 by 3 matrix. For example, let me give an example. 1 0 1 2 1 0 0 0 3. Yeah. As I said before, we have to find its determinant. For finding its determinant, a determinant is equal to. We select the 1 first of all, and if we select this 1, let me cover this, and there are these numbers we have to write 1. As I said before here, we for finding is AD minus CB, and 3 minus 0 is 3, and minus now we take 0, and if you take 0 it's we have 2 0 and 0 3, and for finding it again 0 and it's 6 minus 0 it's 6, never mind, it's 0, and plus we cover this 1, and there's a number 2 minus 0, it's we have to write 1, and 2 minus 0 it's 2. For finding it, if we calculate, it's 3 minus 0 plus 2, it's 5. Determinant A is 5. We find determinant is 5. Let me give another matrix. This matrix, yeah. We keep it. If we cover this one, we have to find its multiplication 3 and 0 minus 0, it's 3, and we have to cover this one, and it's 6, and we have to cover this, and it's 0. And the second row we have to keep this, and the number is 3 0 minus 0, it's 0, and we have to keep this row, and the number is this, and it's 3, and select this, and we keep this one, and the number is this, it's 0. And the third row, we keep this, and the number is this 0 minus, it's minus 1, and we keep this and this, the number is this, it's minus 2, and the last one we keep this and this row, the number is this, it is 1. Let me change its sign, for example. Plus 3 minus plus minus plus minus plus minus plus, and the matrix is 3 minus 6 0 0 3 0, and minus 1 minus minus, it's plus 2 and 1. For finding inverse of A, A is equal to, we have to keep the diagonal, therefore we have to write 3 3 1, and we change its place. Minus 1 0, and we change this place, minus 6 0, and we change this place 0 2. 1 over determinant A, and the determinant is a 5. We find this, therefore 1 over 5, and 3 0 minus 1 minus 6 3 2 0 0 1. If we calculate this, we will find the inverse of A. Here with determinant, it's not 2, it's 0, therefore the determinant is 3, and here it's 1 over 3, therefore you can find its inverse. Let me find determinant of n by n matrix, A matrix n by n. For example, it's a little bit bigger one, A 1 1, A 1 2, A 1 3, something at A 1 n, and there A 2 1, something and something, and A n 1, A n n. If you remember, in there, for finding its determinant, we select this one and we cover this, and there are some numbers here, and we find multiply 3 and this 3 multiple 1 minus 0 multiple 0, and we find this one. And in here, for finding its determinant A is equal to, we have to keep it A 1 1 and multiple, if we keep this and keep this, there are numbers in here, and let's call it determinant A 1 1, and minus, let's go to A 1 2, minus, we keep it minus 2, and we keep this row and this column, and the number is this and this, and it's called determinant A 1 2, and plus, and let's go to there, A 1 2 multiply determinant A 1 3 and minus, plus, and in here a minus n, 1n, and determinant a1n. Yes, and it's the determinant of a matrix m by n.